So, ladies and gentlemen, so we have next session. We have to little organize ourselves. We talk about cyber security in operational technology by Rizwan Anwar. So I think he's there. Session. Anwar, are you there? Hmm? Yeah. So let me check if you can unmute and
Yeah, yes, I'm here.
you're
Can you
there,
hear me?
right? Okay.
Can
Yeah,
you
yeah,
hear
I
me?
can hear you.
Yeah,
Yeah, yeah.
thank you.
So, Anwar, okay. Yeah, okay. So I can hear you. Yeah. So, can you, Jyoti, can you make Anwar presenter also? So that,
Yes, sir. I have added him as a presenter.
okay. So let me give a quick introduction to Rizwan. So Rizwan, he's a professional in the OT, the operational technology, especially the cybersecurity. So fortunately, during my last visit, I met Anwar in the flight, and then we had very interesting talk. Okay, so
Yeah,
coincidentally, we share common interests. So we talk about MES, and he talk about the OT part of it, the sensors and the actuators, especially in the electrical engineering part kind of thing. So it was very insightful to talk to him. So I requested for to give a quick insights for 30 minutes. So he humbly accepted my invite to join. So let me give a quick round of introduction to Anwar. Okay, so Anwar, Muhammad Rizwan Anwar is a systems architect in OT cybersecurity solutions. So he is an MBA graduate with power management from University of Petroleum and Minerals, Energy, Electrical Engineering, and his primary interest in OT cybersecurity. So ISA framework. So he is a member of ISA, member of CI, GRE, IE, IEEE, Saudi Council of Engineers, and IEI, India. So he's very well into cybersecurity for OT. So I would like to hear you of Anwarji. So please feel comfortable and then give us a brief. Now that the topic we are talking today is the supply chain and manufacturing part. So how does that help uh, to connect the cybersecurity with all this AI revolution? So over to you, Rizwan.
yeah, thank you, Mr. Abdul Qadir. Pleasure meeting you and give a brief introduction about me. And this is Rizwan Anwar here. I'm working in the OT field for about past 15 years, and I have worked with various customers in Middle East and India. So today my talk is about briefly about how OT solutions are, and then how the manufacturing and execution systems are interconnected. And you see the digitization process now. And I will give you a brief introduction and explain you how we can make value out of this one, and then provide a better solution to our customers. So thank you for inviting me, Mr. Abdul Qadir, for this webinar. See my screen?
You can see your screen, yes.
Yeah, great. So when you are implementing, so actually if you see any manufacturing plant or any process plant or any company which is producing product, so they have a systems interconnected. So whenever the raw materials come in, the process takes place, and then the manufacturing systems will be implementing. All these systems are interconnected, and then when you see there is a supply chain connected to it, then all the implementation systems, and then you will have a final product. So when you try to implement an OT solution, so assist and secure those process for those OT systems, you see like any weakest point in this whole loop chain. So from sourcing of the material, products, process, and all this till the customer implementation solution. So you see, whenever there is a weak point, any one of the weak points will be could be lead to your break in the process, production down, or all this. So systems are only secure up to their weakest point. So you can say that any OT system, any process plant, or any manufacturing plant will be secure, or the whole business continuity will be depend on their one of the weakest point. And then you have to implement security when you try to implement any OT security solution. So you should be well aware of the process. So what is the factory process? What is the manufacturing process? How the products move from one stage to another stage, and all this. So if you don't understand the process and try to implement this process for the manufacturing execution systems, so you don't understand the process, and then you don't catch the weak points. So you cannot have full-fledged implementation of security for the OT. Then physical access, and then you should have people who are trying to support any manufacturing plant will have access from their customers or the product vendors or the machine manufacturers try to support you for the breakdown. So all this should be recorded and processed. So over the period of time, you see this is the map showing different type of attacks happened on the process systems in different regions. So you see the ratings there. By the more red it is, like the more attacks were happened in these regions. So this is the attacks and the percentage of attacks prevented on all these regions by South Africa, Middle East, and this. So if you see here that Middle East got around 34% of penetration, like by hackers try to malicious inside, sometimes malicious insiders on all this process will be affecting the business continuity. So one of the attacks happened here in many regions and try to implement countermeasures for those. So when you are trying to counter for any kind of process, so you should understand what are there different entities involved, what are the different process involved in the OT, so that you implement a proper design solution to prevent any kind of attack on those. So if you see here, should follow some kind of framework, right? So this is the NIST cybersecurity framework, which was defined by NIST, National Institute of Science and Technology in US, which defines that how to identify different systems in the process. So you should have so you should identify your systems, protect those systems, and detect any malicious or detect any outsider access to your systems. So sometimes, many process plants, many manufacturing plants, due to competition, so they will try to implement all those systems, but they don't have any detection mechanisms inside their
Correct.
systems, so that what is going on in the process. And then you should also have a response. So how you implement your response plan. Something machine is broken down in your manufacturing process. So what is your mechanism to do a response and analysis and mitigation of that? And then after all this, sometimes even you try your best, but you cannot avoid some kind of breakdown in any area, in any process plant. So you should see how use your recur plan. So NIST mainly defines about identify. First, you need to identify your process systems, had a proper governance, do a risk assessment, risk management strategy, and your supply chain risk management strategy. And then you should also have protection mechanism. So how you are protecting these assets. So you should have a physical security, then you have a cyber security implementation, and then what are the process systems? You should give access to only the people who have access. So give the right information and right access to the people who need. So give them the right information that as much they need. So least privilege. So you should give them the least privilege access. Don't give every access to the systems process for everyone. Then you have also have a detection mechanism, which is the process is identified and it is continuously monitoring the process. So in case if you can also use this system to do mitigations for your systems and future planning and like this. So in OT, many attacks happened over the years, as I showed you in the previous slide. So the attackers and the process is getting complex and complex, and then people who are managing these systems are having very less tools to defend it. So the attackers are evolving like every bad actors from sometimes it may be a competition or a nation state attack or anything. So process will be the offensive side, like the hackers or the people who are trying to affect your plant. are already continuously evolving techniques. So same side we have as who is defending the teams, the CISO, cybersecurity, OT security, and the OT people who process managements, and all these teams also should continuously evolve their knowledge on this process so that they have all the advanced knowledge on this. So as far as you know, cybersecurity and AI and all these are getting implemented. So you should always evolve your team. So training and awareness very important for your internal resources. So when they are aware, so they will be taking the right actions and right time. And there is many systems getting implemented. So many initiatives by many governments. So NCA in Saudi and many countries, they are bringing now regulatory compliance for those implementing these systems. And you should also perform regular risk assessments on your process. And then you should have a SOC, like Security Operations Center, not for physical, but also for cyber. Then you have to have reports generation. So automatically how secure we are, what was the previous metrics, what was our milestone we reached, and then like this. Then also you should have a proper identity and access management inside your organization whenever who is accessing your factory process. So how to
sorry,
yeah.
Anand,
Yeah.
so this training and awareness, I think
Yeah.
this is very, very important. Now, with everybody is using all kind of devices, and
Yeah.
it is exposed to the internet connectivities, and
Yeah.
everybody is open their browsers. Okay, and then you also have the security requirement for the servers. So how does that training take place usually? So how do you plan for the entire? Do you plan for the entire organization, or is it for the teams? How do you do that?
One of the main things which IEC 62443, I will explain about that standard coming, which defines about clear communication. So whenever there is any strategy, whenever there is any process change, so you should clearly communicate. So all of your team should be aware. And for the training and awareness, everyone should have a basic level of understanding how they are using these systems. So sometimes, some organizations have a policy that they don't allow any mobile devices. Some organizations, they don't allow internet access. So all this process which is going on in the company, everyone should have a basic level of training on the security minimum policy requirements. Then over that, specific training for each sector. So a manufacturing team should have a specific oriented training for there, and the IT team who is providing internet access, they should have a different level of training like this. So there is many courses, like basic thing is CompTIA Security Plus and Network Plus training for the IT team. And there is IEC 62443, the fundamentals of operational cyber security. This is also one of the trainings which is available in the market, which they can go for a process plants.
Yeah.
So
Please.
So here, if you see how is the implementation and what are the standards that govern implementing a process plant security. So NERCSIP. So NERCSIP is Northern American Reliability Corporation, which defines that critical infrastructure protection. So which has a regulation that there will be should be a must for the companies or the product manufacturing entities who are implementing like any mission or mission critical or nation state production. So NIST is another standard which is defines about cybersecurity framework. Just the previous slide which I described, the identify, protect, detect, discover. So NIST is also providing one of the basic guidelines for, as you ask, training and awareness. This is also one of the trainings they should be concentrate. So this is a must for everyone, NIST. And then there is Department of Homeland Security, which is advanced level of security for like banks and all these companies who are managing the financial transactions like this. And then IEC 61850 is mainly for the communication inside the electrical utility. And 62443 is the key standard that everyone in the process plant or manufacturing industry should have this. And recently there is one more European standard, NIS, National Information Security Directive 2 was released, and this is also required in European countries. So each regional and each country has different approach to implementing the cybersecurity for OT. So if you see, when you try to, if you see a process, an OT OT is very wide, right? You have a oil, you have electrical, you have a process PLC system, and you have all the chemical process which is going on, or in a factory which is producing products. So there is a chain of systems. So inside these systems, there is the systems architecture is very complex. So each process
Mhm.
is interconnected, and then there is number of nodes. So many process PLCs devices are interconnected, and they are already interlinked to do an action. So if there is a process break or a step happen in one PLC or one step, then the next process will stop. So when
Correct.
you don't have any proper implementation, so there is a cascaded failure. And then all this access, so all this access to the systems, and then how you can implement this solution is you have to divide the whole process plant, whole factory into zones. So first you have to divide which is your critical zone. So which are your crown jewels, like crown jewels in the terms of you have a process of any manufacturing company. So there is a critical process inside your whole process chain from raw material to the finished product. Okay. So when you should define, so what is your critical process, and I have to protect it. If it is broken down, so whole my manufacturing will be down. So you have to identify what are your critical assets and what are your non-critical assets. Based on that assets, you have to divide them into zones. So critical and non-critical zones. And if you see in OT, as OT is controlling the real world. So if you see a traffic signal, or if you see a manufacturing plant, so if it is broken or if it is down for a day, so huge loss in revenue and in terms
Yes.
of process safety. Like, so you are trying to get a drinkable water or a juice. So some chemicals composition is defined when in pharmaceutical industry or any food processing industry. So you define all process, chemical process, right? So if there is no safety in this, so it will have a disaster with the final finished product. So some kind of chemical may be increased in the drinks which they offer like this. So it is connected to the process, physical world. So
Yes.
in general, if you see how IT and OT differ, so in IT, you see like availability.
It's very important,
Yeah,
Rizwan. So many people don't know about OT.
yeah,
Okay, I tell you honestly. Okay,
yes,
so especially those who are in supply chain and also to some extent manufacturing. They know OT, but they don't use the terminology. Okay,
yeah,
so they may call it sensors, they may call it an actuators,
our
PLC,
process.
PCS. They know this, SCADA. They know this, but all these things which work on the shop floor to you to collect the data, manage the securities, to deliver the to control the production kind of thing. Whatever. So this all things are called OT. Okay,
Yeah,
and then these things can be integrated to the IT, which
yes,
is there is an integration layer, and from there the MES is get connected, and this MES work as a bridge between this OT and then your business systems like ERP. So many people
yeah,
don't know about this, and
yeah,
you are also a member of ISA. So I
yeah.
see that it's very important. So please, can you just brief as much as possible?
Sure, sure. So if you see an IT system, so IT is generally who are the people who are managing your servers, and you're managing your telephone communications, or managing your email servers. So for if you consider any organization, if there is a downside on their email server, so it will not affect much of the company's process, right? So even email is down, so it will be up after half an hour or 1 hour. It has no impact, so still they can call someone and inform him. So in IT process, you see the CIA, confidentiality, integrity, and availability. So confidentiality is more important inside an IT side, so that what is going on in your email, so like this. And then availability is not much important for them. So for them, the confidentiality is important, then integrity of the data, and then availability. So these are the data and services the IT is taking care. But when it comes to the OT side, so if you have a process plant where the packaging things or the labeling things, or you are adding some kind of dosage of a chemical into a process, so for that the PLC or the logic which is running on that PLC, availability is more important in the OT than confidentiality and integrity. So the PLC should do and action take an action on that step. So if it doesn't happen, and whole process will be down, or it will create a disaster for the manufacturing plant. So I will show you now, as Mr. Abdul Kader has pointed, very wise thing, that how they are interconnected. So all these systems. So OT in general, it is a process which is connected to the physical world. IT is like email servers or whatever you are communicating over the Zoom meeting. Like, so all these things are not are important for our business critical needs, but it doesn't have a physical impact. But OT has a physical impact for the physical world. So I will show you, like, as Mr. Abdul Kader has explained before. So how you
Yeah,
mentioned the
this is-
layer. So this is the
yeah.
layer which you are talking about. So any manufacturing plant, you have a machines at the layer 1, level 0 and level 1, and which are controlled. The machines are the motors which are controlled by the PLC and the SCADA systems. And these SCADA systems will provide process information to MES. So what is the production order right now? How much production they need to make in this month, and all this information. And then again, it's interlinked to the ERPs like business systems. So Purdue level architecture. So this Purdue level architecture is very important to understand. This was developed by Purdue University. So that's why it's named as after that university as Purdue level architecture for ICS. So level, you have to identify that information exchange happens over these layers. So straight away, machines cannot communicate with the ERP systems. Whenever machines communicate with the ERP systems, you see that there could be an attack on that. So because machine will be connected to internet. So it should go through process, like machines will be communicate to PLCs, PLCs will communicate to MES, and MES will communicate. So all the process, the data flow is from down to up. If any layer bypasses the other layer, then you can understand that this will create an issue in the compliance issue with the process later. So this is brief, one use case I will explain here, like briefly how the MES. So MES is in the level 3 here. So how you segment
Yeah.
these layers? So process is at the level 0. So your machine,
Mhm.
sensors, actuators, robots. So nowadays you see many of the industries are going to add robots instead of manual labor. So for accuracy and
Correct.
timely actions. So you machines are running
Mhm.
24/7. Nobody is monitoring them. So all these systems, when they produce, when they are interconnected and they are doing any actions on the process, so you see nobody is monitoring them. There are some factories last month. You heard about the news that the Tesla vehicle was straight away delivered from the factory to the owner. So there is no
Mm.
middleman, no sales. So the vehicle drove itself from the Tesla
Ah.
factory and then
Mhm.
reached to the customer. So there is no middle in process. So this is now more automatic process. So when you don't monitor this kind of OT systems, so the vehicle could be tampered, and then the communication can be tampered, then anyone can drive the vehicle. So all these systems nowadays, factories are getting automated. They are getting added by robots. AI is getting introduced. So when this process straight away is connected to internet, you will see that there could be a possible attack on those systems. So when you don't follow this Purdue level architecture, so the systems machines will talk to. Let me show my pointer here. Yeah. So here, if you see the process level machines should talk to the PLCs, and PLCs will talk to the HMI and the SCADA systems. And then there is an engineering access, so device management. The company right now, which I work for, Subnet, so they have device management solution for configuring all those, managing those devices. Then we have another layer, which is like all the process historian, and these systems is called demilitarized zone. At this layer, you segment the process from the IT systems by adding a DMZ layer, wherein any process from IT or enterprise system will pass through the DMZ and reach to the OT. So if enterprise level directly access the level 3, then you cannot control the process. So Purdue level architecture is clearly defines how you have zones, and then how you implement the conduits, and then how the process information will reach the business systems. If you bypass anything from level 4 to level 2 and level 4 to level 3 without DMZ, then you cannot have a control about the process.
Yeah.
There can be, because IT systems are continuously connected to internet, but the factories are also getting connected nowadays. But should we implement this process and go by layers to provide the information to the IT, OT, and then IoT applications are getting up, and then AI.
Very, very interesting.
Yeah.
Can we stay here? So it's
Yes.
one important observation based on after talking to so many organizations. Okay.
Yeah.
So many organizations, they have fragmented level 0, level 1, and level 2. Okay. So they have control HMI and SCADA processes for a set of shop floor. And then there
Yeah.
are standalone machines which have their own control, manual control. Okay, maybe it is controlled separate as a standalone individual. Okay, like CNC machine kind of thing. Now
Yeah.
the thing is, these machines and then your PLCs are not connected each other. They are doing a standalone process. Now they have ERP in place, which is a business application. Now they expect
Yeah.
that all these things will be connected automatically, and then they get the benefit of AI. Okay, so which is
No.
really not
No.
possible. Now here, the key point here is, now if you have a level 0 and level 1 things, now all these things should be connected to level 3, and then you need to get the benefit of level 4, which is a DMZ. Okay, that's where you get the data readiness. Okay, so you
Yeah.
get the data readiness for using it for AI or any other things. Okay, so without that,
Yes.
your data is not ready. Okay, so since if we don't have the
Yeah.
data readiness, how can we apply AI for that? It's not possible. Okay, so that's very important point. What do you think? So the DMZ layer and level 3 are very important. Okay, so that they get the benefit for the level 5 and also for the other part of the business.
Yeah, thank you for pointing this out. So actually, if you see many process plant, you have standalone systems, because why they have a standalone system? Any manufacturer of a machine component or a skid which they supply, they design the solution up to their process only. They don't care
Correct.
how this system is interconnected to other systems
Correct.
as a IT level. But at the process level, yes, they define how the packaged product will come into his, and then he will apply label, and then he will process to the next step. So they are very concentrated on the level 2 and level 3 layer only, but they will not concentrate how this system again will be connected to SAP or other process systems. So when there is a standalone systems also, again the organization should bring his all the experts to one table, and then connect these integrated systems, and then to a DMZ. They should form a layer called DMZ layer. From that layer, they should provide access to any systems upper level, like level 4, to access the information. Then they can whatever information collected through DMZ, then they can apply the AI models, then they can
AI
apply any
models.
kind of learning
Yeah.
mechanisms. So all this process info, if they just straight away involve IT or the AI process into the level 1 and level 3, then they will jeopardize the process itself, because each process is
Whole
not
process.
whole process get affected. So for standalone systems also, they can connect to the level 2 and level 3 side, then go send this information over this firewall, then provide access to the files are getting issued. So there is next generation file. Even at the firewall level, there is an implementation of AI models now. So they are trying to understand each and every packet which is going up. So they understand the process nowadays. Previously, the firewalls were built for IT. Now they are building firewalls for OT, which understand the protocol, Modbus protocol, PLC, and like this.
So are you
So
talking about the protocol somewhere in the presentation? So if you are
yeah, I
talking
will
about that,
talk
then it
about
would be great. Fantastic. Yeah.
great. Yeah, I will talk. So when you see critical system zone, so how you divide the system into different zones. So as you see, like if it was overall like a architecture, but here you will see the users. So you have a business users like supply chain team, or procurement team, they are non-critical, but they don't have connection to they have connection to the process, but they are directly not involved on the production side. But they are the people who bring you the orders, the people who bring you the raw material, but they don't have access to the production machines. The production users are critical users, the people who configure the PLCs, the people who configure the CNC, the people who manage this process are different from the people who are managing the business. So you have to isolate these systems from logical point of view, and then also through a next generation firewall. So you should define them in zones. So critical zone and non-critical zone. Because how you define a zone is like the people who are in the same, who apply same cyber security policy, you can apply similar policy for them. And the people who are in the critical zone are having a different set of policies. So this critical zone people not allowed to connect to internet. But the non-critical zone people are need access to the business email, need access to the portals, company portals, or SAP systems. But critical zone people are not needed to connect to business systems. And then you should have an implemented protocol detection system at the process level, which understands that which machine is communicating with which machine, which robot is now connected to another robot, or maybe some process plant have direct access to internet. So you don't want this. So you can detect this, why you need this, because if your IT systems is continuously connected to internet, the possibility of getting attack is chances are higher. But process plant you should isolate, okay, through a next generation firewall.
Perfect.
So if there will be no lateral movement, like if any user laptop gets hacked, the malware will not go to your process plant. So you segment those zones. So you have a firewall in middle here, a next generation firewall redundant. Then IT systems can go through this firewall only, and then you have a detection system for your own OT, and you have a detection system in your IT side. So for any kind of malware, any external access, so your process, so your employees are working in one, but somebody can access your plant from remotely. So you can know from the detection system that someone is and this system is isolated over span. So you mirror the traffic. So how we implement this solution is, the process network will have all the switches and PLCs connected. So you take the copy of the traffic and then you ingest the traffic into a detection sensor from different manufacturers like Nozomi, Forescout, Dragos, Tenable. So you implement this network injection into this, and then they have protocol level detection that which machine is supposed to communicate with which machine. So there is 4 robots in that any process plant, but you configured them to communicate for two robots, but 1, 2, 3, 4, suddenly in middle of the night, that robot 4 is communicating with robot 1, but you didn't intend to communicate this. But this happened over middle of the night. This detection system can give you alert like why this robot is connecting. So this meaning someone externally trying to configure it. Maybe it's your own engineer, or maybe an external hacker trying to access this robot machine and then trying to jump over to the other robot. So
the critical zone have to be separated.
Separated. Yeah, the process plant is considered as a critical zone. Your business process, the people who are accessing the IT, the portals, office, and the manufacturing systems should be isolated from the this one. So why we do this one is mainly to break the lateral movement. So your IT got attacked so that your OT is still safe. It didn't affect your process plant, manufacturing plant. So zoning. So zoning, as I explained, this is very, very important. You have to define the systems into zones, and then communication, interzone communication. So how the interzone communication will happen, and each user will have a 2-factor authentication at the IT level and a process level like this. So all this protocol. So if you see here, I can see intrusion prevention system. So when there is any communication going on from one PLC to other PLC, or one robot to other robot, or one system to another robot, so you see here the packets will go from one system to the here. We use 104 protocol in the energy side. So maybe in some of the manufacturing process use Modbus or Profinet, or like this Modbus and like this. So when there is a protocol level communication going on, so you understand the packet. So if you have a capture of the packet, what is going on, I can define that what this robot is giving a command to another system. So once they understand the system, so they can implement an easy way of brute force attack or a DDoS attack like this. So these next generation firewall or intrusion prevention systems have advantage. They can understand the process protocol itself. Is it a command, or is it an information, or is it only someone is trying to access the PLC like this? So they can understand deep packet inspection. They can do a deep packet inspection of the process and then give you an alarm, so somebody can take action on that. So this is also
Okay.
another approach for prevention. So how you prevent? So the layer, this IPS is like here, the firewall, the DMZ firewall. So someone IT system is accessing OT system. So they have deep communication, deep packet inspection. So is it a legit communication, or it is someone unauthorized trying to access your process? So these are the next generation firewalls doing this one. So this is the next generation firewall trying to implement like on access to the OT systems. So why should we have a detection on OT? So OT, you know, the process is not monitored mostly in many manufacturing plants now. There is automated process, or people who are aware of the managing these CMCs. Some manufacturing plants run 24/7. Okay, so you should have a 24/7 monitoring also. Who is accessing, from where they are accessing, what manipulation they are doing on the code, what is doing on what the machines are doing, and how is the production level going on. All this process in data should be ingested into a detection system, and this detection system can help you to identify is there any penetration. So this is a process plant architecture. So here, if you see, we are using 61850 protocol, and this is one of the solution from a vendor. There, they are collecting the traffic from the process. So IO and the PLC. From the process, they are connecting a mirrored traffic to a sensor. So they are collecting all the information, what is going on in the process, are ingested into a sensor. This sensor have AI and next generation modeling done, so that they understand what is going on inside the process. And they are not connected actively. So if you see this dotted communication and this solid line, they are this is active communication, this is passive. This system cannot have any impact on that, because there is algorithms running in this process on the data which is collected. So if you see, this is passively connecting, so it is not actively connected to the process, because process is very critical. So if this gets system attacked, and then it gets attacked. So they are collecting the traffic and process by mirror traffic. They are completely mirroring the process. So you know now there is a concept of digital twin or the digital factory. So all the data of the factory is ingested to a sensor passively, and then they will analyze this data passively. So it will not have any impact on that. Then they can collect from multiple plants, like isolated plants. So sensor here, they ingest to a central, and then they can also have a sensor in the level 3, and all this information can be provided on a one dashboard for the user to all monitor out what's the process going on and intercommunications happening and alerts, and can be given for the process plant. So this is the layers. So what are the OT layers? As I explained, as a logical, physical wise, we saw 0, 1, level 1, level 2, level 3 DMZ. But this is as a logical process. So you should have an technology partner ecosystems at the OT level. Then you should have enforcement layer at the OT. Then you have a control orchestration. Then you have a policy from the top down can be implemented till the OT layer. This is one of the another process architecture which is like defining the same one which I showed you logically, that sensors are in the level 0, then you have PLCs and RTUs or whatever devices connected, then you have a SCADA, HMI local, then you have an historian at level 3 and it jump server at DMZ, then you have IT and IT security getting implemented.
Perfect.
And one more important systems that is nowadays needed inside the OT is like the authentication, or the people who are accessing the systems should be and people who are remotely engineering. So you bought a machine from any manufacturer is based in Europe or US, and then you are trying to give him the access to troubleshoot your machine breakdown like this, right? So you provide remote access to that machine, but the communication you are using is public media, right? So you are using internet, then he is using the internet in that country and trying to access. So during this process, so there is all the traffic, all the information about your machine will be going through the internet. So you give the access to the right people with right level of permissions. So there is LDAP, lightweight active directory, and then there is one more role-based access control. Even if you need to implement it in your inside your factory, so the users have right authentication, AAA authentication, authorization, and accounting. So you should implement this kind of access like fingerprint based or access card, or someone is trying to shut down your machine, someone is trying to change the configuration, that he have right permissions to access that device or no. Be it a SCADA engineer, be it a PLC, or be it a CNC engineer who is trying to configure those machines, should have a privileged access, and you are monitoring and controlling their access. And at least if you are not controlling their access right now, but at least you have the data for monitoring. So somebody changed this in this day, so this affected the process. So you have a record, system of record for that. So another system that is very, very important is a SIEM solution, which is collecting all the data from your process plants and switches, routers, workstations, feeding into a system called SIEM, sequence of events, which is like event management. But all this information will be sent through this system, has a bigger picture. So what is the logs going on? All this. So this is like a syslog protocol, which is used for collecting all this information and feeding it to a central platform wherein you can have all logging when someone try to access this PLC, which date and what changes he did. All logs from that PLC can be pushed. So any switch is modified. So anyone enabled a new port on the switch, why he enabled, what was the reason, and if you can have all this record inside the same solution.
So is it like a CM is something like a now is there any standard for this?
Yeah, some of the solutions in the market is like this is a syslog standard. Syslog, the standard for that is a syslog. So coming slide, I will show you how the data is pushed into that. Like, so another way of providing security on the devices itself is like you have a system hardening. Like you implemented overall solution, but you put the password 123, or you put the password admin. So what is the purpose of implementing all these mission critical expensive systems, but the password inside Allen Bradley PLC is still Allen or admin or 123? So anyone who knows, he will try to access by default password or a very user friendly password for remembrance, but it has an impact on your process, right? So you should have a procedure for password management, network management, and you should implement these systems, because whatever process you consider, but the people are not aware. So who is trying to click a malicious link, or he's trying to keep the password admin like this? So you should give awareness to your people, so that at least they should have a complex passwords, and they should give access to the right people, and all these devices, even at the process level, should be hardened. So is there any switch which in the PLC which is open, so somebody can bring a laptop or bring a mobile phone and connect it to that switch and change the configuration? But because the reason was you didn't disable the port. There are 14 ports in that switch, but the process uses only 4 ports. Still there is 10 ports, unused ports, so you should disable those ports by default. So this is system hardening. Then one more mechanism is like you should also have a patch management system, which is like continuously update your process or office systems. You should have an antivirus software, and then update the patch. So every time there is a new malware, new virus coming up, So in the market, so you have a patch management system which can be applied the patch to that right PLC, right switch, and like this. So you should have implemented a patch management system also. So you
Mhm.
can have an automatic or a backup. You can do manual process or you can do an automatic. But for OT you have to have a critical validated. So you should have a production and you should have a pre-production or a demo. Therein you first apply that patch to that PLC or that apply to that switch, test it has behavior, then apply in the production environment. So if you see the structure which I am going through is like identify, protect, detect, respond, recover. So here till here you saw that it was all the process to prevent and detect. Now it is a respond and recover. So you should have a mechanism to implement backups of your process or PLCs. So HMI, straight away your process was configured, HMI was configured from some engineer. He came down the way from US or UK. You has configured PLCs and all the process was implemented and then left. Then you don't have a
Yeah, like,
backup. So this is
okay.
one of the critical systems. You should have a backup in case of disaster recovery. So you should collect backups of your HMI, backup of your SCADA software. All this should be backup and put it in an external hard disk so that whenever is there a breakdown, you can refer to that data. And then one more mechanism. So this is one of the PLCs. So you see PLCs got IOs, PLCs got output cards, and then they got communication cards. So all
Mhm.
this hardware should have a defense in depth concept. So you see in a fortress will have like a level 1. You should cross level 1 security, then physical security, then you go by physical, like in the airport. So first you go to the air and in the airport you drop your baggage, then you have a physical security check. Then even after that physical security, your baggage will be checked. Then again your body will be scanned. Same way you should have a defense in depth concept. So system hardening, as I explained before, the ports are disabled, the unused ports are disabled, and the people who have access only. Then the people who have access are radius like role-based access are provided like based on his role. So somebody can from another process don't have access on this PLC and he don't have access to the other process, other CNC machine. Then segmentation.
Mhm.
Then you have encryption of the data going out. So you see the data coming out of PLC is going by layers and people who have access, and then you have an syslog, though you have monitoring, continuous monitoring of that device. So this is like defense in depth approach for any process PLC or HMI. All this should be implemented in the OT side. So this is one of the defense in depth. So first is the process plant security. Then you should have a network security. Then you see the system integrity in the core. So, and the boundary you see here is the physical security at the first. So anyone accessing the factory should have a physical security. So there is a barbed wire and physical process going on. Then once he entered the plant, he will go to only where he was allowed to go, not go everywhere of the process plant. Then you have a network security, how they are connected, and then you have system integrated at the core. So by this way, you can implement an proper OT implementation for any factory or any process plant. So this is the approach we have to follow in the defense in depth. It is same like a castle I explained. So you have a boundary wall, then inside wall, then you can reach to the core. So there is different mechanisms now. Many devices use Modbus, parameterization, 61850 parameter system access, as I explained. So you should limit the access to the devices by web server. Nobody should get access to a PLC by web server. Okay, we do it normally, but from now you should not have this practice. So the laptop he is trying to access got a virus. This virus is again jumped onto the process plant through any switch, and then it will propagate to the whole plant and you have a downtime.
Correct.
So IT is as a must. There is a certification for IT is ISO, but for OT devices it is IEC 62443. So the right people have access to the right devices, right process, and for right time only, not every time. So you give him the reach privilege. So he's supposed to access the system for 5 days. After 5 days, the process password, all this should be modified. So this is the standard which you mentioned, the SIEM system which
Mhm.
were asking. This is the
Mhm.
information which we push to the syslog. So there is any machine, any process, you got an warning messages, alerts, critical informations, errors. All this information are accumulated in one same solution. So this you can correlate. So any process plant or factory has a downtime, then what was the reason? So you can trace back what first error happened, then this warning happened, and then this step happened. So all this can be traced back in the system same through syslog protocol. Most of the VLCs, most of the process systems support this protocol. So this is the syslog process. So syslog messages will come from all the different systems and then will be accumulated in one place. So you can see the metrics. So how much time the machine was down, how much more time the system was up, who was using it, who logged in. So I accessed the HMI application in the middle of the night. What was done by me? Then I logged out. Somebody else logged in. Then other user tried to log in and do something. Then suddenly process was broken. So you can see who logged in at what time, and all this process will be recorded in the same solution. So these are the well-known solutions. Splunk is one of the biggest solutions for syslog monitoring. So this doesn't has any impact on the process, but it collects all logs and monitoring
Always.
information in single place. So this is like backing up, how you should have your backup data files stored and then encrypted, and all this information should be done. So hope I covered most of my topic. So if you have any questions.
So I could not stop even for the 10 seconds, your lecture.
Yeah.
Because actually I was looking for something like this to bring it. But maybe it's a coincidence that I got you and okay. So thank you, Anwar, for joining and giving a wonderful lecture. And I really enjoyed session. I'm sure this is a action-packed session with the technology. Now we talked yesterday everything about AI, IoT, blockchain. We talk about supply chain optimizations, IIoT, and systems, automations. But everything is connected to cybersecurity. Okay, so if you don't manage cybersecurity well for both OT and IT systems, then you have a big problem. Okay, so that is the reason the cybersecurity as a domain. Okay, now it's a booming now actually. Okay, so even in the engineering,
Yeah.
so there is a specialty for computer science graduates for cybersecurity. It's a very very important domain. Okay, and I think you did it very fantastic lecture, Anwar, clarified many things. I hope the participants from all the channels, from Zoom, from you, from from LinkedIn, so all the channels, people get benefit of this. So thank you very much, Anwar. Would you like to give
Thank you
any
for
final thoughts, share about it? Anwar is an engineer, so if anybody wants to have a word with Anwar, anything related to OT and also cyber security,
OT security. Yeah.
OT cyber security, then please feel free. Okay, so his information also will be posted in the portal. The video will be recorded and be shared. Okay. So, and if any questions, please feel free.